Hello, everyone. So I'm going to be the first person to do a coding interview in the Metaverse. Who do we have here? Ruben? What's up?
Yeah, my name is Ruben.
What's up? Can you give a background on
Um,
yourself?
yeah, I'll give a little bit of background. Like our last guy, I'm a current junior at Georgia Tech. I'm interning at a small finance company in Chicago. Last summer, I interned as a network engineer at another small company located right outside of Chicago.
Nice.
And yeah, I have around 450 LeetCode questions solved,
Wow, 450 leak
most of
code.
which I did. Yeah, most of it I did a few months ago, so I haven't been that active on it as of recently, but
Okay. When's the last time you touched leak code? Has it been a while?
oh no, I try to always do the daily, but like I'm not out here doing like 3 or 4 questions a day like I used to.
I see. I see. Okay, so how are you with the different algorithms? How are you with graphs?
Um, I'd say across the board, just 6 or 7. I mean, I think I'm better than average on all of them, but I'm not like a 8 or a 9. I'm not
I
like
see.
insanely cracked, so
I see. Okay, let me look
I
for a
think I
first
have a
question.
good breadth of questions.
Let me
Sounds good.
look for a first question. Give me a sec. Give me a sec. Let me pause this quick. Okay, I'm gonna post in the very first question.
Okay,
You ready?
sounds good.
Okay.
Yeah. Okay.
Let me fix up the. What's your language of choice for
Python
these?
for sure.
All right, bet.
Yeah.
So wait, let me fix up the example.
Yep.
I need to figure out how to connect my computer to my AirPods or to my VR set. Okay, perfect. All right, so let me explain this to you. Wait, there you go.
Yep.
So you're given an m by n integer matrix grid, and you're given three integers: row, column, and color. Each value in the grid represents the color of the grid square at that location. Basically, the goal is to color around each color. Wait, let me read
Okay.
it. What am I saying? Okay, I'll let you read it actually. I can barely read with this VR.
Okay. Yeah. All right. So just give me a couple minutes. I'm gonna read it on my own, and then I'll try to reiterate and see if I understand correctly.
Mhm. Gotta hit the ad. Don't worry, I'm only gonna do a couple of mocks like this. I gotta at least try one out. Wait, I can't. What's up? Are you here still?
Yeah, I'm here.
Okay,
Sorry,
just
I'm
reading
just trying
it.
to. Yeah, I'm just trying to understand the question. I've read it, but I'm looking through the examples, and I'm just trying to make sense of the examples.
What the heck is this question asking?
Okay.
On. It's tweaking.
Okay.
Chat saying. So what are you thinking so far?
Yeah. So first, by looking at this question, reminds me of a similar question that I've seen, um, which requires for a DFS, and that's what I'm thinking,
Wait, could you
but I
explain what the
can't make.
question is asking to the chat?
Yeah. So basically, you're given an n by n grid, and then you're going to be given a row and a column number, and then you want to color around it, from what I see. So like, we're given two squares that are called adjacent, and let's see. Yeah. And then each number corresponds to like a different color, I guess you could say. So like in
Wait,
here,
could
these are,
you format that to be a grid? Like turn it into a grid instead of the one-dimensional thing.
yeah, like
Might
this.
be easier. Yeah.
Okay, yeah. So like
Okay.
here we have this. I can do it for everyone, I guess.
I see.
And then for this one, we can do the same thing. All right, and then we can do the same with the answers.
Yo, chat. It's way better quality. Like in this VR, it's kind of like tweaked out a little bit. So. Why'd you keep tweaking?
Okay, so the question itself makes sense to me in my head. And especially this third example makes a lot of sense. So like if we're at grid 1 1 because it gives us row 1. Can you see my highlights?
Yeah, I can see your highlights.
Yeah. So if it gives us row 1 column 1, this it would be this one right here. And so what we would want to do is color it to the color, so everything in the 0th and 2nd would be color 2, and then around it would be 2. So I'm struggling to see for 1 and 2 how it's coloring around it. So like if we're given 0 0 in example 1, that would be this one right here. And then I would think that you would color around it, so that would be 2 because these are the same colors, but instead it's coloring itself, if that makes sense.
Wait, okay, let me read the question. Let me read the question. Yeah, my hand. Oh. So two squares are adjacent if they are next to each other. Two squares belong to the same connected component if they have the same color. You should color the border of the connected component that contains the square grid. Oh, what the? Oh no. Alright. No way. How do I unzoom? Uh oh.
Are you stuck?
I'm stuck. Wait, let me check. Wait, how do I unzoom? Yo. Wait. How do I unzoom? Uh, wait. Let me pause quick. We are back on track.
Yeah, did you see what I was talking about with the examples?
Yeah, you just need to color the border, right? So it says you should color the border of the connected component. So since you're giving 0 0, you have to color the border of the ones with 3. But since it's just all ones, it's just all colored with 3, right? And same with what's 0 and 1? 0 and 1?
0 1 would be here. This
Yeah, and
row.
you see that it colors that as well with threes.
Yeah. Okay. Okay. Okay.
Okay,
Okay.
and then
So we
and then
want to.
now look at the one. It
Yeah.
colors. If you turn output into take the output and turn it into twos, or turn it into rows, and you'll see that it wants you to color the middle ones, like basically the border of that of ones with the color two, and you see how that turns out into twos all around that one.
Yeah. Okay. Okay. All right. So I'm gonna go through my thoughts in the here. We'll delete the constraints for now, and then I'll just go through my thoughts right here.
Sure.
So inside of our current color, we want to color the border, right?
Yeah.
So what I mean by this is in the third example, I think this is the best example. It's all ones, but we want the border of the ones. So like these are at the top, so they're technically at the border. Um, and then the ones around it, so like to the left and right of 1, 1, these are also in the current group. And then the ones at the bottom, of course. So we want to color the border. Um, so right off the bat, we know that this is a grid problem or a matrix problem. So we either want to use a DFS or a BFS. Um, I'm unsure of which is going to be easiest right now, but I'm just gonna try to think my way through it. And we also need to think about um, how to determine if it's a border or not.
Yeah.
Okay, so let's see.
We just need to basically paint the border of whatever cell we get.
Yeah, yeah. So like here, let's go through example one. So we're given 0, 0, and then I guess itself can be considered a border as well since it's colored in as 3. So you always want to color in yourself. We can make a note of that. So we always want to color the starting point with color, if that makes sense. And then I assume we want to go through all of them. Now we figure out, no, never mind. We don't always want to. Okay. So example 3 refutes that. We don't always want to color it with the itself. So how do we know if we want to color ourselves? So let's look at 1. Go
Yeah.
here. Okay. So we're given 0, 1. So that's going to be this 2. Oh, okay. So I have a clarifying question.
Sure.
Um, is the border considered like, okay, so let me set up my own example. Um, if we have like something like this, I'm just gonna make this all ones and then we'll do something.
Something is at a border if it's to the right of the actual border of the grid, or
Yeah.
it's to like a non color, not the same color. So
Okay.
if it's at
Okay.
a one and
So
it sees a two, if it's a one and it sees a three, that means it's at a border.
okay. So clarifying. So if we were given this is our row column, this 2 right here in the middle, would these around it be considered the border?
Which one?
If this 2 right here, this 2 in the middle,
Yep.
if we were given that, would these 2 on the
Yep.
outside
Yep. Yep.
be considered
I
the
mean
border? Okay.
that's example three right there, right?
Yeah, yeah, I guess
Yeah.
so.
Yeah.
But I made it a bit longer because I didn't know if it meant the actual like border as in like the end of the array, if that makes sense. Okay,
No. It's like
that sounds good.
anything that's on the
Okay.
actual border should get counted.
Yeah. Okay. So I think right now what we want to do is opt for a DFS solution. At least that seems the most intuitive to me. And I'm trying to think about how to discover, how to not discover, but how to know if it's a border or not. So Say for instance, we're at this 2, we've made our way to this 2. How do we know that this is a border? We know that's a border in the top or at the bottom because it's at the 0th or the last row. Also the same with the columns, or if it's next to 1, right?
Yeah. How do
So
you know if
let's,
something's a border? Yeah.
yeah. I'm just trying to think about how to format the DFS. Let's think. We do this and we treat it. Yeah. Hmm.
Wait, why are you given a row and a column? Well, you're given a row and column because it tells you what
That's your
cell you
start.
just to start at, right? It
Yeah.
tells you this is the cell you start at, and just paint the color of the border from this cell. You understand the question, right? There's
Yeah, yeah,
nothing wrong
I
with it.
understand the question perfectly. I'm just
Yeah.
trying to
Okay.
think about how I want to approach this.
Okay. What are your thoughts? Like, what are the different ways that you're thinking of solving it? Maybe write down a
Yeah,
few
so
notes.
since it's a graph, I know that we need to use either a DFS or a BFS. And this question sort of reminds me of a question like number of islands. So I'm kind of siding with the DFS. But the issue that I'm coming to is how to figure out whether the current row and column that we're at in the DFS is a border or not, right? So like if we're at a border, we know we want to color it color. Um, and getting there, we want to stay inside of like our current. I'm gonna call it an island, I guess, because like or like inside of our current color because we want to color the color. So like we could do a DFS or a BFS throughout our current color, and then once we reach the border of our current color, then we know we want to color it this color, and then we just eventually return that once our DFS or BFS is terminated. So just trying to think, how would I do this? So we obviously want to
Honestly,
maintain
I
like
don't
a
think it
visited set.
matters if it's gonna be a BFS or DFS. The thing that matters is when you get to a border, you color it.
Yeah. Okay. So I'm thinking if we were to use a BFS, we want to use a queue, and then we want to add our first row and column to it. Go through the surrounding and determine whether it's a border. That's that's what we want to do. So hmm, okay. Sorry, I'm really just trying to think. I'm still thinking about how to determine if it's a border. So if it's next to a number, another number, it's a border.
How you're thinking about how to determine if it's a border?
Yeah,
Same
like
thing.
yeah, like
Well, when you get to a node, how do you know if it's a border? Well, if you look up and it's out of bounds, or you look up and it's the number is not the same number as you know it's a border, right?
yeah. The
So
easy way to do this would be using a DFS or a BFS, treating it like number of islands per se, and then for every row or column we visit in there, we change it to the color. But the problem with that is that it's coloring everything inside of that group of color and not just the border.
We'll just do. How can you modify that approach?
Yeah.
It's like,
So we know
what do you
that
need
if it's
to do to modify that approach?
okay, so let's just state some nouns. It's considered a border if we're at like the end of an array or like the beginning, right? So like if we're at row 0, we know that it's going to be a border. If we're at the last row, we know it's going to be a border, or if we're at the last column or first column, it's going to be a border. Um, we also know it's a border if it's next to another number.
That's not itself, right?
Yeah, that's not itself. Okay. So then how do we check for that? Okay. So in this example, we're given 0, 0. So if we use the DFS, we find that here it's the last, here's the last. So then we change it to 3, 3. Here is also the last. So I guess we can include itself because itself is on the edge. Okay, that makes sense. And then 0, 1, that's going to be this 2 here. So then all the numbers in the group would be this 2, these are on the edge. So it would be changed. And it's next to another number. Okay. Okay. I think here I'm going to opt in for using a DFS.
Sure.
I think it just seems like the most intuitive to me. So let me just write down how I would use it. So first we want to call a DFS starting at our original row column, right? So our call will look something like DFS row column. We would pass it in. Um, kind of just doing pseudocode. Um, if we're out of bounds, we're out of bounds, just return, right? There might be a separate return condition. Um, and then we'll make like another separate function outside of the DFS, like is border or something. Um, so we'll say like to do is border that takes in something. And then if is border, then our uh, grid row column is going to be equal to our color.
I think it
And then
makes
what
sense.
we're going to,
You don't have to write it in the comments. You could just straight implement it.
I know, I just like going through it like this
I
first,
see.
and then I'll
Okay,
go
that
through
makes sense.
like my own example or something, just to make sure that it makes sense and like logically
I
it
see.
makes sense before I get into the hard implementation.
Okay.
Um, so if it is a border, then we're gonna color it the color, and then I think we would just want to go through like directions. So like for ACE, ARAC, and we'll do like directions. So 0, 1, or a DFS on this. No. Column, and then it would be something like that. That makes sense to me. And then at the end, we just return our grid. Now, the problem is the is border. If we're out of bounds, or
Who joined?
Our current color doesn't equal the original color. We just want to return because we want to stay inside of our current color group. And then we also want a visited set because we don't want to keep going. So we'll say like visited. Who was that?
I don't know, people just joining. You know.
Okay. Or we have
Don't worry
visited
about it.
the current row column. This makes sense to me. There might be some edge cases in this, but we'll continue with that. Now, how to do is border. Is border. We're gonna take in a row column. We know that. And then how do we determine? So we said if it's on the edge of the grid, then it's a border. So we want to return true. And then at the end, if none of these cases meet, we always want to return false. So what are the cases? If it's on the edge of the grid, like here, 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 then we know it is. Or if it's next to another number. So I guess, would we just check every direction? Check every direction to see if it's next to another number? Guess that would work. Hmm. So if it touches the edge. Okay. Let's go through like everything next to it. So like go through those in all directions next to it. Sorry if this isn't understandable. I'm doing like half English, half actual Python. If cell next to it. True. Okay. I actually think this makes sense. What do you think of this? What do you think of this approach?
Wait, can you explain it?
Yeah, so basically we're gonna call a DFS,
Yep.
and this works by staying inside of the current number. So if we're out of bounds or we're not at our original color, then we're just gonna return, right? Because we don't want to be there.
Yep.
Or if we visited it because we don't want like to go somewhere infinitely many times. And then after that, we're gonna check. I forgot something. We're gonna add it to visited, but our current row column, right? Anyways, if it is at a border, we're gonna color it the color that's specified,
Yep.
and then we're gonna go in all different directions, and then we're gonna run DFS on that new different direction, and we're gonna keep doing that until we've eventually colored in all the borders in theory. And then the is border function works by checking if it's on the edge of the grid. Then we're gonna return true because we specified that like if it's on the edge, then it's considered a border. And then
Yep.
if it's, we're gonna go through all the cells next to it, right? So like on the outside, and if it's next to another number, then we're gonna return true, meaning that it is a border. Else, we're just gonna return false.
Yep. Makes sense.
Okay. So I'm gonna move forward with implementation, and then we'll see how this goes. Okay. Um, Actually, for most of this, I can just take this and we'll see what we'll do. Okay. We'll take this if we're out of bounds. So out of bounds. So check out of bounds. So if rows.
The avatar editor.
Zero. Equal original color. So we'll define a variable called like original. Going to be grid of the original row column. Original color. Or row column and visited. We're going to do this. Oh, what am I doing? Making this a set. Okay. We don't have grid defined, but that's fine for now. All of this is going to be in like, and then we're going to be given a row column and a color. We're also going to be given a grid, but that's fine. At the end, we want to return the grid, and then we want to make change. So right now, I'm just writing out the DFS function that I specified earlier, changing some variable names so that we don't have any conflicts. Yeah, okay. So now for its border, okay. Oh. This is what we said we want to do. So now how do we want to I think we can take the code from below and use this. Now we can do this. If any of this doesn't make sense, I can clarify.
No, 100% makes sense.
Okay. So now,
Just some water.
to return true. All right. Is there a problem with the indentation? And then if it's on the edge of the grid, okay. So it should make sense, right? So if 0, 0, 0. We're gonna return true. Else at the end, we're gonna return false. Um, so let's go through a couple of these cases to see if it functions as expected. This return false should be here. So let's see. We're gonna go through a DFS that's gonna make sure. Or grid. Okay. So for example, 1 grid. We're gonna start at our current row column. So let's make sure we actually call the DFS here. DFS on our row column. And we're gonna start here. Move here. Stay there. It is on the edge. Then it gets colored. This also gets colored. This gets colored. When we get to the 2, we return and it goes unbothered. Okay, that should work correctly. And then now we start at 0, 1, so we're at the 2. 2 gets colored. This 2 also gets colored. This would also get colored. That makes sense. These all make sense. Yeah, does this make sense to you? Do you think we're clear to run?
Wait, walk me through line by line.
Yeah, okay. So for we'll start here. Color border, this is just like the parent function for it all. Like for the test cases. So we're obviously going to be given a grid, we're going to be given a row, column, and then the color that they want us to color it in as.
Yep.
Where row column is like your starting point.
Sure.
And then here we have a variable called original color, and this is just like to keep track of what our original color was, like that's different from this one.
Yes.
And then we have a visited set because we don't want to visit any of the same things twice or more than that potentially.
Yep.
And now for is border, this first check is checking whether it's on the edge. So if the row is 0, column is 0, or it's at the last row or column, oh, -1. Glad I
Okay.
got that.
Nice. This is why we do walkthroughs.
Yeah. So if it's on the edge, we want to return true because that means it's a border. And then now we're going through every direction. ARAC just stands for add row, add column. It's just something I've always done. And then
Yep.
we calculate the new row and the new column based on this. Basically what this is doing is it should be checking like everything next to it. And if we encounter something that is inbounds and it's a different color from the original color, then that means it's a border and we just immediately return true. And if it's not at like the border of the matrix or it's not next to a new color, then we just return false. And then in the DFS, we go through and if it's out of bounds or it's not the original color or we've already visited
Wait,
it,
so if
we
it's in
return.
between those, if it's in between, we return true. That means it is a border.
Oh, no. So here we're just checking if it's in bounds and the color isn't the original color. Because here we check
Okay.
for, it would never call on something out of bounds because here in the DFS we check for out of bounds.
I see. I see. I see.
And
Okay.
so here we check for out of bounds and then here's where we call it.
I see.
So we add it to visited. So we make sure that it never like revisits it. So this shouldn't be called on something like that we've already visited like more than once. And then if this returns true, let's add the parameters. So we said we want a row column, so our current row column. So if our current row column meets one of these two conditions, then we color it in with the specified color. Otherwise, we just continue in all the other different directions and make sure that we are inside of the same original color.
I feel like if the okay, okay, run it onto a few examples and just make sure it's working correctly.
Yeah, I ran it through. Hopefully I'm not gaslighting myself, but I think it would work. So like here, I'll take my self-made example.
Or just
Um,
like actually
oh,
do some test cases, like run it on some
oh,
test cases
okay.
and print out the result.
Yeah, sure, sure. Um, so instead of let's print the grid as well. Um, now we're gonna have a grid like this. Grid, and then a row column will make it something better. And it doesn't matter. We'll make it like 0, 3. Or here, we'll just use one of the actual examples.
Yeah, let's just use one of the actual inputs and outputs here.
Okay. Yeah. Okay.
Let's use
So we'll
example
do
3.
this.
That one's more complicated.
Okay, for sure. We'll do this. Um, we'll use color border. Do this, and then just pass in 1, 1, 2. Do something it doesn't like. We'll print this. Okay. Run. What is the expected? 2, 2, 1, 2, 2, 2, 2. Okay, so this example looks like it works. Do you see that on your screen?
Yep.
Let's use example 2.
Wait. Go back down.
Yeah,
It doesn't look like it's. Oh wait. Can you print it out in rows? Like instead of saying print grid, loop through the rows and then print the rows, just to make it.
yeah. Print
Well,
row.
that won't do anything. But if you
Oh,
do like for row and grid, and then do the print inside the for loop.
yeah, okay. Like this?
Yeah. Print it.
Okay. Oh, this is
Okay.
it's just doing it twice because I'm also returning. We can get rid of this for now, I guess. And we'll run
Nice.
non-return type. That looks correct for 3. Does it
Add some ones
same for?
around it, or like some twos around it, just to make sure.
Okay.
Add
In
another row of twos in the first one right over here. Right there.
okay, right here. What 2s? Like this?
I can't see.
That's fine.
Mess it
We'll
up.
do this. Yeah, and then that one stays the same. What if we add more ones?
God. Messed up my screen again.
Yeah, this looks like it works for at least this example.
Mm-hmm.
Would you like me to run another example?
Okay, a sec. Wait, tweaked out my screen. Dude, this VR is annoying me now. Thanks for being the first person in the metaverse to do an interview, though.
I'm honored.
Tweak it.
Who's Jay?
Oh, that's me. That's the second account.
Oh, that's your second one.
Refresh this. Okay, wait. Dude, this thing's annoying. Okay. How do I... Can run the code? Switch language.
Yeah, you want me to run it now?
Wait, give me a second.
Yeah, no problem.
Okay, quick tip. How to make your
How to zoom in and out. I'll zoom this thing.
Zoomed out now.
All right. How's the algorithm looking?
To me, it looked fine. For the third test case, it worked. I haven't tested example 1 and 2, but it worked for example 3.
All right. Okay, cool. How do you think you did?
I think it took me a long time to like get the question or like at least think about how to determine if it's a border. I think that was relatively trivial. Like once I actually thought about it, I
Yeah.
think it was just nerves. But I think besides that, I think um I did okay on implementation. I don't see any bugs, at least the first time I ran it. And then I caught like the off by one errors, but I think I did
I
okay.
see.
Not the best, not the worst.
Yeah. The main thing is, what I would say, is just moving faster on it. I think you knew how to implement the algorithm. The main thing that tripped you out is the border. But when
Yeah,
you really
yeah.
just thought about it, it actually wasn't bad, right? It's just you know when it's a border based on these conditions.
Yeah, exactly.
So I think for you, it's more just like getting to there faster. But you write the code bug free and everything. It just took a little bit to get there. But
How long was that?
little bit of it was technical difficulties. So the interview was 50 minutes.
Oh, that was 50 minutes? Oh, holy. Okay.
Yeah, but you're just rusty, I think, because you said you haven't done it in a while.
Yeah,
So
I haven't like gone hard in because I have, I got my offer and I just stopped grinding,
yeah,
I guess.
the algorithm looks good. Let's see. Yeah, no real
What would you
complaints.
say it was? Do you think that would be a pass or a fail?
Let me think. I think because it took too long, I was hoping to ask two questions. It wouldn't have been a pass. Oh,
Yeah, that makes sense.
because I was gonna ask two questions. So usually, if they don't take, if they're not fast enough to do two questions, it's not a pass.
Yeah, that makes sense.
Okay, but there's some technical difficulties. Okay, I'm retiring this metaverse interview. The heck is this? Yeah. Let's see. Thanks for taking the time out.
Yeah, no problem. Thank you so much for interviewing me.
Appreciate it. Appreciate it. Yeah, let me
All right,
know
see you
when you
later.
want to do. We'll do a real one when I'm actually more focused because I was the whole time I was trying to focus on getting this thing working.
Yeah, we'll hit a real one pretty soon.
All right. Good luck
All
with
right, well,
everything.
see ya.
All right.
Thanks. See
See ya.
ya.
Bye.